All right, let's focus on networks. So when it comes to networks, I want you to review minimum spanning tree and its applications. But it will not sometimes be straight away. But first understand the definition of a minimum spanning tree. Of a network has the weight edges, okay, which the total of all the edges when you add, like for example, a tree means your goal is connecting all of your vertices, but not all edges may be used. Correct? Like for example, you may have something like this kind of a network, but technically you just have to connect all, let's say these are all your houses and you have to run a power cable. You don't want to waste where it is not needed. As long as all the houses have the electric cable running, that's enough for you. The goal of these spanning trees is making sure that all vertices are connected, but you don't include all the edges. It's not necessary. So you need to choose the ones with minimum weights. So that should be your goal, and keep the minimum weights and see how best you can add to your new picture. So you need to be able to draw and show the new picture with the minimum weights and justify why you chose these. Now, the other concept also can emerge from this is, what are the possible values of any new edge that you would like to add, but it should not change the overall not change the overall weight. Okay, so remember the minimum spanning tree means the total have to be the sum of all the edges that will fetch you to the least value. The smaller the value, that is your best minimum spanning tree. And it can also ask you what it cannot be. So you can have different drawings as long as the value will not change. Okay, so the least value should not change. Please make sure that you understand this concept. Okay, usually on the test they may not ask you the difference between what is Prim's algorithm, what is Kruskal's algorithm, but if you want to, you can always refer to our cards that I provided, card number 91 and 92. But otherwise just review directly from the textbook. Okay, so minimum spanning tree. That's it, guys.